on voting technology in 2006. The title of Ted's talk today is Understanding Considerate Systems. Let's give him a welcome.
Well, thank you very much. That's a very sweet introduction. Yeah, I'm kind of just a lifelong inventor, and there's a variety of things one does. This service to the country idea after the 2000 election kind of turned into a big thing, and I can't shake it. So we're working. We have funding from the Election Assistance Commission to work at Berkeley on voting with disabilities, and we'll talk about that a little bit later in the hour. I'll start by just saying that this is a digital cigarette, and the digital cigarette represents a lot of what people do. They want to represent themselves to themselves. When they have a cigarette, they feel like they're taking a break or looking cool or defining themselves as not a Marlboro but a Camel guy or things like that. They're representing themselves to other people. They're helping motivate their great American novel with a big ashtray full of cigarettes. They're doing they're making all of these social statements. They're giving somebody a cigarette. They're asking for a light as a way of breaking some social barriers. And in fact, some kinds of technology, like an iPad or iPhone or something, it does some of this social lubrication by simply being brand new. And others, like this watch that was designed in 1913, isn't about that at all. And it's funny that I'm wearing this watch because I used to just love digital watches, and I still do. But somehow, anyway, the fashion of analog watches. I mean, have you checked out this year? It's like one's this big, on women, right? So anyway, everything that we make, in some sense, is to project who we are, and also to make ourselves feel comfortable. And I think that's just one of the issues. Even a cigarette, in some sense, is about the relationship between us and the world. I have been, thinking about a variety of ways of understanding how people interact with each other through technology for a long, long time. My context-aware computing group thought about how to use automatic models of systems, of users and tasks to support improved performance in natural and even dangerous settings. I was talking earlier today with some people about how I made these. We're doing disabilities people. Where are you? Where I got to be in Good Morning America, laying in bed. It was a great thing. But what I was doing is that I was using eye tracking to control my world. Because my head is on a pillow, it's stabilized. Because and I can, even if I have a quadriplegic or whatever, I can stare at the ceiling and control my world. But what was different about the way I did it was that I kind of did a lot of the first work showing that eye position is not nearly as important as eye gesture. And when people are staring at something, my dog starts barking when I do this, actually. When I put these glasses on, one photodiode looks at my eye, and it can tell if I'm staring, blinking nervously, falling asleep, winking. And so when you're interacting with the world from this bed, we're using a gesture language that's about social communication to decide how to react and how to use what the person does. And what's different about that than the eye tracking, the historic eye tracking approach, and this is kind of how I distinguish myself, is that I think about what are the social implications and what are the social, what does a person actually do. And in this case, people will lay down in that bed, and with 10 seconds of instruction, I can get them to successfully control their world with blinks, winks, staring and not, and they'll just lay there for 10 minutes showing it off to everybody else. As opposed to typical eye tracking systems where you can you can try as you will. And the fact is, to the extent that you're editing text by looking at it, first of all, it's shaking. Second of all, you can't keep track of the tiger that's coming after you. It's very, very unpleasant. And so I think that a lot of my Considerate system stance is about how do we understand what the social implications of interface requests are. Anyway, there's a bunch of stuff up here. I didn't mean to get into that one so much, but we've done stuff that makes it so that when you're doing email, it reacts to and helps you know whether you're what the social statement you're making to another person is: surprised, angry, happy, sad. An email, how should I be responding? Which of the emails is most important for me to respond? And we were able to actually make a system where people succeeded at responding to emails they wanted to much more, even though our training, our AI training data was only 65 to 75% correct. So that's a statement about making user experiences where, in fact, it's a collaboration, and we don't make opaque interfaces that only allow a person to succeed if the computer understands it deeply, but rather ones that, partnership ones, where, in fact, a person, in this case, they read the same amount of emails as they would with a normal email system, but they actually succeed better at responding to the ones correct, and they like it better. So there's a whole lot of different things I've done that's on this page, and I've spent too much time on it, I guess. So this idea of context-aware computing is using dynamic models of user, system, and task to maximize implicit communication. That is, what you're doing is enough for the system to respond, so you're not filling out forms and stuff like that. And I spent a lot of time making things like that smart door and this smart floor that did things like that. Considerate is that we respond with social models. And what I discovered was that all of those context-aware demos you saw on that last page, and you'll hear me talk about it a little bit, only succeeded, and I do performance, I'm an experimental designer. A lot of my work, I build stuff, but then I test it. Only succeeded when it had a social model of response. And that's why you'll keep hearing me kind of trying to emphasize that. Yeah. And then feed forward, Considerate systems will great to see you to everybody that comes into the restaurant, and I'm wearing my best clothes, right? Feedback, is, the guy falls on the floor and I actually respond differently to him than the people that walk in through. And a lot of things like for example, Firefox, when it crashes, it say, well, this is embarrassing, right? It says it no matter what. This is embarrassing. That's not with feedback, but it implies a social model, and it does, diffuse some of the frustration. All right. In the interest of time, we aren't going to go too much. It's a system that behaves. That displays an awareness of the state of the user and the situation in social context by behaving in ways that support human, and human-machine interactions being appropriate. Okay, I'm not going to go much more deeply, except that, what we're about to start thinking about here is I'm going to show an example of where I really want to show that I could improve human-human communication with a considerate agent that without a person intruding, and I do that with an audio system that you're going to see in a minute. But so when we're interacting with people, and talking, we've got all of these different ways in person to signal social responses. But when we're talking, I'm just going to move through. I'm going to go back to that. But when we are, and so we want our communication to be pertinent and valuable, thoughtful and caring, receptive and reciprocal. It should not be distracting, disruptive, condescending, hostile, or manipulative. Most computer interfaces have been made so that they have an expectation, their model of the user is that they know all the error codes and they expect every response that the computer makes. Well, we all know that there are surprises every 3 minutes when you're working with a computer, and that is exactly down in this distracting, condescending, and hostile. Actually, just the act of it reacting and popping something up on the screen is typically a distraction, and that's not probably all that helpful. So I'm going to talk about first an example from Car Coach, a system I made in a car that really got me on this Considerate kick. And then I'll talk about the disruption manager, which is a global manager of what you're doing on a computer. And finally, I'll talk about this audio system I alluded to earlier. And then I'm sorry, but we're going to have to talk about voting because it's CITRIS. So we had this car. It was called the Chrysler 300M IT Edition, and it had 209 sensors in it. And I got sick of playing with that, and I decided I was just going to use what was on the CAN2 bus. Just the steering wheel, the brakes, the gas, the blinker was all I'm going to use. And so I did some experiments about could people learn a new skill. So the skill was to go very, very slowly around a corner, not accelerating. And so it's a skill that you don't actually use in driving, but it requires you to be trying to drive. And what we found was that you had to keep the RPM under 4,500 RPM, so you don't accelerate. And we wanted it to be something you had to learn. And what we found was that when we gave them feedback while they were doing it, they actually didn't learn it as well as if we gave feedback a second later. And that was a big surprise to me because I always thought, instant feedback's important. Well, actually, maybe not when you are cognitively loaded, right? When you're not able to pay attention, when it's you're doing something that takes a lot of concentration, that was our goal. Then, in fact, relating to it is better than doing it at the same time. And so that was kind of interesting. I said, all right, can I make a person drive better by having an automated response to your driving? And I call it Car Coach. I made something called Coach years ago, which you might even know about for adaptive help system. But so what I did is that I had criticisms and affirmations. So if you turn with signaling, it says thank you for signaling. If you smoothly accelerate, it says smooth driving, or the seat vibrates. I had this vibration system and an audio system also. But you notice there's a lot of criticisms here. Brake gently, easy on the gas, signal please. And when we first showed this to the press, they loved this stuff. They'd get away from the curb and it'd say, blinker please, and they'd giggle, and then they'd start using the blinker, and we thought we'd had something great. Then we ran experiments, and we found out that we were wrong. We found out that actually when you give much feedback that's negative, people drive worse. You see these errors. Basically negative feedback, here it is, you make more mistakes as soon as we start giving you negative feedback, and less mistakes when you start giving positive feedback. And in fact, what we discovered was that if you want to give negative feedback, a scheduled reinforcement, that is that, a diet of 5 times as much positive than negative, and by the way, almost never any, right? As soon as we gave too much of anything, you'll see the errors start going up for positive also.
So you've got a coach that you could give the parents who are teaching their teenager to drive that
would improve their driving.
It also, I use this, I need this to explain to my wife why when she's with me, I drive worse.
Right, and what that's right. Well, we all do, and it's because it's distracting, and all those things. The little list at the bottom of that page that I had back there. It's condescending, right? And so what was amazing is that we were actually, with this audio feedback and these few sensors, actually able to improve people's driving, right? That was pretty exciting. Hey, anybody want to make a company? We'll do it. But that was my, and it was this model of feedback that really comes from behavior mod, and translated over, and I realized it's a social model I needed to succeed. Okay, I'll give you another example. This is Ernesto Arroyo's thesis, was a disruption manager. And disruption manager, we had We used Open Mind. It's a common sense reasoning system to recognize when you're editing text or when a text message was coming in, what was the relationship between it and other messages that were coming in semantically, not because it did, it was just comparing them and using this big basically repository of things that people say. And what we were able to do is using these, are you typing? Are you using the mouse? Are you reading something? Are you looking at something like just delaying text messages, SMSs, by up to 2 minutes, and then reorganizing them so that the text messages that were about the same topic might be together, only delayed by 2 minutes. We were able to greatly change the interaction. So what the scenario was is you've got this poor person trying to take orders, and they've got a spreadsheet they're filling out, and there's order form, and they're getting some email requesting they're going to buy something, and they got to use a calculator to figure out the price, and they got some SMSs coming in about personal things, and also coming in from their boss about changes in policy or changes in order. And what we found is that when we asked them, hey, make fewer errors, be careful, we could get them to be to 30% fewer errors. And if we ask the same person, go faster, 25% faster. So it was their goal that we were succeeding by just rearranging these texts so that they were less disruptive, so they were respecting what else they were doing and maybe a little bit about them, it was able to actually improve their performance. In a very common, this was like a task that was so hard that these poor people, after an hour and a half, we had to have them have a coffee break because, it really, because, there's a lot of things to keep track. It was a typical office task of the past. Maybe now things are simpler, but very proud of this. Again, let's go make a company, right? Third scenario that we've done more recently, and there's a paper in DIS last year and in Interact just a couple months ago about this stuff. We said, can we improve audio communication? And why audio? Because it's about the thinnest natural communication channel we could think of, and because already it's kind of, in a conference call, pretty overloaded. And so I thought, well, if I add something to it and improve it, I'll be really proud of myself. Well, we spent a year and a half making it worse. There's a lot of, I can tell you, lots of ways of trying to identify a person or what's going on that actually distracts, disrupts, slows down the communication. But, it's amazing. People really find the ability to share content much worse on audio-only conference call than face-to-face meeting, those people I was showing on that slide at the beginning. On the other hand, the question is, can we improve it? And we have this idea of that we were talking about before of an intentional stance, social actions, activity recognition, and then feedback. We want it to be the intentional stance to be considerate, and we want advisory and assistive response. What advisory means is I'm telling you something, and assistive, I'm doing something for you. I like advisory things because they teach, but we tried both. Here's some of the problems that we tried to tackle. We looked at meeting problems, and the ones that we thought we could do something about might be that it's not well facilitated, it has too much noise, it's difficult to identify who is speaking, and to find out who was or wasn't in the meeting. So we started off with some signal processing to find out who's speaking a lot. And we had this experiment where the two people in different rooms are spelling out a word, taking choices, actually collaborating to agree which letter they're going to try in a hangman game. So they're trying to say, is there an A in the word? Is there a C in the word? And so we started off, mapping how much people talked, and there's always somebody that's more dominant, and they continue being more dominant. This is the person that wasn't talking very much, and they're talking some because we require them to acknowledge the decision as they're making these. And then we turned on this thing that said, and believe it or not, it was a lot of work to figure out what to say, but here's what it said.
Turn taking.
It said that to the most dominant person. And you can see that green line just drops immediately. This whole time frame is like 3 minutes. They just drop immediately, and when we say to the other guy, oops, where's my, I gotta find my.
Any thoughts?
They talk a lot more. They go from 20% over here to 40%. Well, 35. So they almost 75% more talking. So that was really exciting that we could actually and by the way, what I found in this particular scenario is afterwards you find yourself asking people, and they hardly remember it happened. And that was what I say is one of the bottom lines of success in this stuff, is that when we started it off by like putting a newsroom behind him and a surf behind me, totally worse. And when I gave him the bass drum and you the guitar, very confusing. So lots of things I thought would matter, like just identifying a person or in these ways did not. Let's see what we started off with things like,
You have been talking for a while. Please give others a turn.
this sucked, right? Okay, yeah. All right. So we got the dominance. We're not going to talk about dominance anymore. We're going to talk about extraneous noise. So we had, you're trying to do something. In this case, you got to get to check in a chess game in 3 moves. Okay, that's the problem, and you're trying to collaborate with somebody again over a distance, and there's a television in the background. So we say, just whenever there's extra noise, just tell the other guy to turn it down. And we find out 2 things. First of all, they are willing to do it once, and unless the noise on the other end is just much, much louder the second time, they won't do it again. Also, if they do tell another person to turn off the sound, the stress of both participants goes up, and we find them actually having more complicated interactions. But when we said this simple thing,
Noisy?
and they were significantly better at doing their job. So with the number of interruptions halved with Cameo on. So in other words, people were more polite to each other when we had the computer make the request to turn off the television.
You did it in audio cue.
Yeah, it's all audio. Everything's in the audio domain. We're not. You can tell me we can do all these things, and we can have image and video. And Joni D'Amico did that as a thesis, but no, I wanted to overload an already busy channel and see if I could improve.
Show you a meter of how much of the time you dominated or something.
Nope, not doing any of that. I'm just trying to, yes, all that stuff can be useful and might make it much better, but I'm seeing if I can do it with even less than that, right? So that's kind of just the thing. And so we got this, okay, I was able to reduce the impact of extraneous noise on the meeting. Okay, the final, the next thing that we tried was identified who's speaking. And that was really interesting. We tried a variety of things, and I'll play one of them.
Lighter.
Hear that
lighter.
ding?
Yeah, it's lighter, but there is no fluid.
There's a lower ding?
Just use the
newspapers.
phone. Yeah.
That's a higher ding?
What?
Newspapers can burn. Okay.
Yeah.
Lower
Yeah.
ding?
Yeah.
So you got the idea. So
Newspaper
what we're using is
audio,
these different
right.
timbres, okay? Whoops. And we tried a whole bunch of different things. I talked about the instrumental background. So there's an instrument behind you that's a guitar and him that's a drum. We tried varying the pitch. between people. Actually, it was very confusing. And actually, what surprised us is that we were able to, see, I'll just get to the results. We were able to, using spatial, that is to put on stereo earphones and place the different people around, is the gold standard. And that one, the accuracy of knowing who's speaking was greatest, and the response time best. But what's exciting is those little bings that I was showing you. Of all the things we tried metaphoric, and we tried concrete, and we tried abstract, and we tried these other. Those little dings worked, and they worked well enough to actually be statistically significantly not different from spatial. A little bit worse, maybe, if you look at them, but not different. They're just better than no cues. And the data that we were using, this was a bunch of Taiwanese non-American speakers having a conversation. So it's a fairly complex thing for us to hear these people speaking in an accent that's not their native tongue, and distinguish them. We've had all this happen. All of us have had this happen on conference calls. Yeah.
Just understand the spatial condition, you have 4 people at separate locations, then you kind of mix them out into space.
Yeah, that's right.
Ultimately disparate space.
In all of these cases, I have 4 people distributed that way. And in one case, I put them out spatially, boom, 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 boom.
Okay.
And the other ones, I just have these little overlaid sounds, a variety of kinds of sounds. And the exciting thing for me is to realize that that these very small sounds identified with them that are almost just I had to tell you about actually made a huge difference on people's performance at knowing who spoke, and
So maybe we've got some data that if you actually just on spatialization, where if you push some people slightly behind you, so there's some, if you take space as being a problem, then you can kind of optimize spatialization.
I'm sure of it, and I think space is, as I said, the gold standard. I think it's really a powerful, thing. It's just a matter of, you got to have two things on both ears, and I think that's fine. I think spatial's really great, but I'm also proud of the fact that we were able to do it without that. And so, who's in the meeting and who's left? And we tried all sorts of things like.
I feel like the lighter may be the most important one because maybe you can gather some grass or some roots by yourself without using axe or using fuel. But you really need
anyway, you can tell it's very difficult.
The starting point.
Nature, we tried putting nature behind them.
I feel like the lighter may be the most important one because maybe you can gather some grass or some roots by yourself without using axe or using fuel.
See, there's a wave.
But you really need the
very difficult.
The starting point.
And
So how about canvas?
Canvas.
ambient
You mean
environment
you can
sounds.
burn, or
I don't know. Canvas. What can you do? Can we burn
you can
canvas?
lay on it?
So we tried stuff, and this presence question, and what we found out was that
So how about canvas?
these auditory
Canvas.
icons.
You mean you can burn, or
I don't know. Canvas. What can you do? Can we burn
you can
canvas?
lay on
You
it?
can hear that typing?
We can just sleep
on canvas?
Yeah,
on
sleep on.
canvas.
Anyway, we got people had to ask who's speaking about half as often with those cues. All right, I'm going to end with an easier one to understand or see, which is what can you do anything to know whether people are entering or exiting the room? And today's teleconferencing system will say something like, Ted Selker has entered the meeting, right? And what we found, just because I'm seeing we're getting already late, is that when we did something like this,
John.
that is entering.
John?
Just putting a little upturn on the end was hugely better than everything else we tried. Well, hugely, you can see it, it's statistical, and that the error rate is reduced to almost half of what it was with
John has entered the meeting.
the typical thing, right? Or,
John,
oh, this was one of our best ideas. We thought, the door opening and the door closing. It takes too much concentration, it takes too much time, and it's not as specific. And we worked on that one for months before we came up with just John, we don't tell people much. They just figure it out.
So when they leave, they just send them down, and it's the down tone when they're leaving? Or
When they're leaving, he goes Ted. Yeah. When they're entering, it says Ted. When they're leaving, it says Ted. Does he exist anymore? And people are. He doesn't. It's like the 3-year-old. He's got. So basically, we were able to make actual improvement in all of these, problems that really are genuine problems in actual conference calls. So I'm really proud of that. And I guess I'm just going to, speak a little bit about a couple of other things, which is just to say that, one of the hardest things about convincing people, which seems obvious now, that you can use these kind of technologies in lots of scenarios, is to make lots. So I'm a constructor. I'm always building stuff, and this, for example, was a kitchen, a office of the future that I made years ago. And I already told you about the digital cigarette, but I really believe that, as well as doing these deeper experiments, like these probes, these scenario probes, where you kind of imagine how things are going to fit into people's lives, is a delight. In terms of fitting into people's lives, what I really enjoy about we're not going to talk about that, about voting as something to study is, first of all, it affects us more powerfully than almost anything. And it is our place where we're supposed to exhibit power. And what I like, as a user interface person, it's kind of interesting that the entire act is completely syntactic. You are just making a mark. It's a transcription of a belief you have, and that would be complicated is a surprise. So what we found in 2000 was that the way I got involved is Nicholas Negroponte sent around a message saying, I have to have a press release in 1 hour about what we're going to do about voting. What do you guys think? So I made the response, the mistake of responding, and I said, anything that you don't do very often, you make mistakes on, and anything that has high consequence is easier to make mistakes on. So he said, great, Ted, and then he used that soundbite, and then I would say, this is a transparent voting machine. It's an end-to-end process where, and this is Ron Rivest walking into it with, we're really. These things are posted that are rules, and then there's, you go in there and you have to do all these things, and there's a lot of steps. Each of the steps can make people make mistakes and be used for fraud. For example, there's been a long history of people putting leaflets in people's houses saying that there'll be a tow truck at the voting place, and so you should be aware that if you come there, your car might be repossessed. And they do that in poor neighborhoods. You know that in Florida they were checking lights, the brake lights of the cars that were coming towards the voting places on the day of election in 2000 to see if they could find people that they could, intimidate. So this always happens, and so the question is, how do we make a process that succeeds? There's a lot of mistakes that get that have been made. From a registration point of view, registration accounted for something million of the 4.6 million, 2.3 I think million of the 4.6 million lost votes that we were able to actually find in the 2000 election. You think you've registered when you've given back a registration sheet to somebody at a convention. Well, if they were somebody hoping to not register you, and they know that at that convention is only people of your race, I mean from your party, maybe they will not put it in, or maybe they will change you from being a Republican to a Democrat. In the 2000 election in November was the election. In March, registration forms were found in the trunk of a car. So it happens. The registration database can be corrupt. In Florida in 2000, there was close to 100,000, 80,000 actually, people who were taken off the registration with probably not enough decisions about whether John Smith was the right John Smith. And it wasn't completely nefarious, but it was more than, let's say that there was one party that was that did much worse in that regard. It was the Democratic Party. Somehow or other, they were taking more off of the Democratic Party than the Republican. Creating a ballot, 1 million of the votes in 2000 that were lost were due to ballot design. The butterfly ballot's a very famous example. Then collecting and deploying technology and materials, collecting workers, training them, deploying them. I was at LA County watching the election one night when it was 3 a.m. They discovered they didn't have one of the ballot boxes, and they went and discovered it behind a door out in the polling place, and they actually rented an airplane to fly it in. I don't know why it was so far away. LA doesn't seem that way. But anyway, they did. And, the question is, did anybody do anything to that ballot box between the time that the election officials left that polling place at 8 p.m. that evening or not? Okay, anyway, so there's been all sorts of things that have happened, and from a disabilities point of view, I might point out that the interesting thing about this, that particular, I get into this too much, oh well, posting of that you have to look at to find out about the polling place is that if you walk up to that, the automatic door will smash you in the face. So what happens is that the way you do polling setup can be really important. For example, polling place problems were 1 million of the votes that were lost. Here is a large group of people waiting at 7 a.m. to go up these stairs and into that polling booth. And we have a famous cryptographer in the picture too. But anyway, the door is this wide, and there are 4 polling places inside. And by the way, the accessible, I don't have a picture here, the accessible entrance is around the back, and you have to go through the cafeteria. But so they had this unnecessarily long line because everybody thought that they were supposed to go through this one door, and actually that isn't the entrance. This stuff happens, and there's a lot of these guys. By the way, these guys kicked ass. This is a polling place with 50,000 people are going to vote in Ward 9, are registered to vote in Ward 9. This is right after Katrina, and they'd had this terrible mess there before because they had this election official that was a mess, and so the guys from Baton Rouge, what's their state capital in Louisiana? It's not Baton Rouge, it's... Okay, Baton Rouge. They came down in force. These guys all came from the state capitol, and they're using poll books. They have ThinkPad computers, I like ThinkPads, with a list of everybody that's supposed to vote and maps of where they're supposed to go. So you come and you go to them, and then you go around. Notice there's no line here. There was no line at any of these polling places in that particular ward because there were people from Baton Rouge out there directing traffic. There were people out there helping people go into the building. There were people helping them know which polling place to go to, and it completely. So we have 10 or 100 times as many people coming in here, and it's no problem compared to that place where there was a huge problem. So these all can improve things, but I could go on all day. I love talking about this, and I know that we're going to run out of time. But here, yeah. So another thing that's really interesting is, most polling places, it's illegal to have any police or governmental officials in the polling place, and there's good reasons for this because there's a history of intimidation and fraud. This particular very helpful policeman in Boston has decided to take over for somebody that went to the bathroom, and he's taken both the registration book that you sign on the way in and the one out on the way out, put them on top of each other, and he's signing both of them at the same time, thereby circumventing the security feature of knowing whether a person with a ballot has left without voting, which is the basis of chain voting. Chain voting is when you can pay someone outside, give them a real ballot, mark it up for them, and have them go in and do it. It used to be alleged to be a big process in Chicago. But you see, who's going to take a guy with a gun and say, I'm sorry, you aren't trained to be a poll worker, actually you might be intimidating people also, and furthermore you're breaking a fundamental security feature of the voting place. So there's a lot of things. One of the things that I finally came to is that I call it single agent independence. Okay, some people talk about software independence. I talk about single agent independence. Single agent independence, but no piece of software all by itself, no person all by themselves should ever make a decision that holds sway. And so, if you take a look at what happened in Volusia County, Florida, in 2000, 16,022 votes were eliminated from their at about 11 p.m. from their record, and they sent it off to Fox News and CNN. Fox News called the election for Bush, and CNN said, "Why do we have fewer votes than we had 10 minutes ago?" In which case, some people went back into the system and found out that somebody, never was identified who, had gone into the back end and just erased 16,022 votes for Democratic people. And so this checks and balances, I say, has to be everywhere. And the real issue isn't whether it's software or hardware, it's whether there are two things checking on each other or more. It has to be actually more than two. And you see her by herself. By the way, this particular individual, I am getting on a rant about voting for you. But anyway, this particular individual, this is after a long weekend. I think it's Labor Day weekend. And she is the only person that is checking whether these voting machines, checking out these voting machines before people vote on them. So if anybody voted on these things during the weekend, we are absolutely needing her to do the beginning of day count correctly. Now, does she look like a person that's like relaxed and working easily? I mean, I want somebody next to her that turns over and uses a different colored pen and gets the same answer she did to verify that was a correct response. And it goes on and on. Each of these pictures I could talk about just forever. But yeah, by the way, this particular picture is actually in that same place where she was taking that down. And the reason that problem occurred was this picture here. This is, notice the blinds behind it? Nobody noticed that red, I took this picture at 7 a.m., that this red screen is up. That red screen says I'm not plugged in. And nobody noticed that because of the contrast difference. They just didn't bother to use that voting machine. Not being plugged in meant that all of them were unplugged. And so what happened is about 10 o'clock, they all went down, and here are all the people waiting. By the way, they plugged it into a socket next to a microwave oven, and by that time, I'd come back and I said, don't you think you want to unplug that microwave? Because 20 machines plugged into it. He said, oh, no. I mean, a poll watcher's not supposed to say anything. I couldn't stand it. There's another piece of a story here, which is the reason these guys are actually sitting around is because giving people ballots, you can see this piece of scrap of paper here. This scrap of paper says precinct 000, and it has a code 1503. What do you think precinct 000 might be? It means no precinct. Okay, that's what's called a provisional ballot. It's for if you don't have if we can't verify you have a registration, we give you a chance to vote, but not for any of the local offices. So all those people are actually sitting around because they're waiting to find out if they can vote for local offices. And the answer was no, because they'd been given the wrong ballot by this woman. And this is in another polling place where they got so pissed off, they moved that number down here to focus on how to give the correct ballot. These are mistakes people make. and I could go on. So what have I been doing? Hey, let's get done with this. Oh God, it's so much fun. By the way, light is a real important part of voting. Those lamps were added about 9:30 in this very dark auditorium that people were voting in. And by the way, do you think really it's good to have 3 people in a ballot place? So, I think it's great to have many people, single-agent independents for checking things, but actually you're supposed to have a private vote. That in this country, anyway. So I've done poll watching all over the country, hundreds of places, and learned lots of stuff. And I've made lots of things, and I'm just going to tell you about some of the ones I'm working on right now at Berkeley. And low error voting interface is this picture up here. And what we found is that by having a ballot, you can see it's a bit of a fisheye. So these are bigger than these. I could actually run it if we had time. And if you vote for a race, then it turns green. So all 3 of those races have been voted on, and none of these down here. And so that redundancy of seeing all the races and seeing what the selection is and getting the feedback, we were able to get 30% fewer errors for voting. Now, just to give you, and this is above a normal electronic voting machine. And just what we do know is that electronic voting machines reduce errors by almost 3 times over paper. So just to give you the example, in 2000, we had 1.9% of people in this country went to the polling place and were not successful at voting for president. Okay? And people said, well, 1% of those are probably protest votes. They went in and didn't want to vote for anybody. But in 2004, where people used paper, 0.9% was the lowest residual, and that's much lower than 1.9, so we're very proud of that. However, in the 4 states that used electronic voting machines, it was 0.4% or less. All of them were 0.4% or less. Why? There's a lot of reasons why. It's not all one thing, but one of the reasons is that they saw a reaction in the machine, and you hear about flipping. Flipping is when they notice that they've voted one thing and it's recorded something else, and then they can change it, as opposed to the experiments we did where we tested what flipping happens in paper, which is probably about the same, which is 0.5% of people in the Gray-Davis recall election voted for the votes on 0.5% more than you would expect voted for the votes on either side of Schwarzenegger, Bustamante, and Gray-Davis. So people mispunch, and people make mistakes. So the only difference is, one difference anyway, is that they can see their mistake. There's a whole lot of other things to talk about. You guys have heard a lot about the dangers of electronic voting machines. It's a very complicated story. So in fact, what happened is it became illegal, mostly in this country, to have voting machines that were electronic. And so I decided, well, what the heck, even though I figured out how to give redundancy and focus people's attention for electronic voting machines, we found, by the way, that for people with dyslexia, which is 14.5% of the population, or people with short-term memory loss, which is 6.5 to 7.5%, that they were getting huge improvements by structuring the vote. And when we were able to step them through it, they would 3 times less errors. So I made this, and this is a magnifier, and it stands on its own, so if you have tremor, you're not having to hold it, and you can put a pen underneath it so that you can make a vote, and it's got a barrel magnifier so that it puts the box over here next to the thing there, doesn't distort them out of the way each other. And the newest, there's about 10,000 of these being used. I haven't made enough money to pay for the mold that I designed for it, but I did it on my own. But the new one that I made, we found that magnifying is helps, and a light helps even more. So we have it illuminated, and it structures people's voting. And we're doing experiments right now at Berkeley to demonstrate that this will reduce errors in ballots the same way, many of the same ways that low error voting interface does. More general thing that we were doing, we just did an experiment where we demonstrated that for write-ins, we were able to, for blind people with write-ins, we're able to double their speed at doing the write-in. Very difficult problem because you can't do type ahead. When somebody starts with an S, you don't want to say Schwarzenegger. You want them to have to spell it out because otherwise you don't know what they really thought. And that's a paper that just got accepted. This is from a class I taught on voting, these two, last summer. And you can see, even at this resolution, that the contrast in that box is not very good. So we are demonstrating on this little box on the right what contrast looks like for some of the text on background in this thing. And by doing that, we make the designer aware of design mistakes they've made that makes things inaccessible. Anything less than 16 point and stuff. And showing how many different fonts are on the screen. And LA is going to start using this. Very excited about that. This is another thing LA is interested in. We had one student make a system for simulating setting up a polling place. And I showed you earlier the little bits of polling place setup problems. And I will be here till 7 p.m. if we want to talk about them a lot. But in any case, I've got, this is showing the checklist for making a seat for somebody to wait in. And so we're going to try using this to help people in LA learn about polling place design. And there's my magnifying glass with its illuminator. You can't, it's a much wider, bigger one than that one I showed you. Anyway, I guess it's time to end. It's after 5. I'm supposed to be somewhere at 6. But I just wanted to say that, tools as they've been using computation, sorry, this was inspired by computational experiments, it isn't one. It used to be about, about transcription and remembering things. But, now everything's about things being personal and personalized and used for social purposes. And that's why I think that this business of understanding the considerate needs of people is important. So I think, thank you very much, and that's about as much as I can say. Maybe a question or two.
Time for a couple questions?
I
Okay.
barely.